Alrighty, so today we're going to be looking at solving for the exact solutions of angles. So this is going to be relying really heavily on our ability to do the exact values the first way. So the first thing that I would be looking at is whenever I see a square root of 3 over 2, I know that that has to be related to this triangle here. So let's just draw it up and let's try to work out where. And we're going to be doing it in, as you can see, radians. So I'm going to put in the radian angle. So it's pi on 6 and pi on 3. So I need to think about from the sine perspective, which is opposite over hypotenuse, what's going to be needed. Well, this would have to be the opposite and this would have to be the hypotenuse, which means that this would have to be the angle. So we now have a reference angle. We know that there is at least one solution, and that first solution is x is equal to pi on 3. That is a perfectly valid solution, right? And we can just get that from the exact triangles. Except, I'm going to tell you that there's not just one solution, there's in fact an infinite number of solutions. Why? Well, that's a solution, but because of the unit circle, if I add 2 pi, well, that's also a solution. And in fact, if I add 4 pi, that's also going to be a solution. And in fact, if I add 6 pi, that's also going to be a solution. So finding the first solution isn't always going to be enough. We're going to sometimes have to add 2 pi and think about whether that is. We can call this what's called the general solution. So if I go plus 2 pi n, for n is some integer, well, that's a way of saying basically that's plus or minus any number of 2 pi's. Because remember, I could have subtracted 2 pi instead of added 2 pi. It's still going to take us a full rotation, in the same way that we could add or subtract 360 degrees. All right, so that's one family of solutions. And in fact, this is an infinite family of solutions. There are an infinite number of solutions there. But that's not the only solution, because as you might know, we didn't want positive root 3 on 2. In fact, we wanted negative root 3 on 2. So that pi on 3 works fine for getting the positive values, but it doesn't work for getting the negatives. So this is where the unit circle is going to come in to help us actually work out what the correct value should be. So let's draw our unit circle, put in our cast. Now we're looking for places where sine is negative. So where is sine negative? Well, sine's negative in the tan quadrant and in the cosine quadrant. So let's draw that reference angle in. Pi on 3 here, and then pi on 3 here, okay? So these are going to be our two reference angles. So let's work out what they are. So let me get rid of my plus 2 pi n business for the minute, alrighty? So let's work out this first angle. I'm going to do it in blue. So this first angle here. Well, this first angle here, x1, well, that's just going to be pi plus pi on 3, which you can work out is going to be 4 pi on 3. The second one, let's do it in green. This one is going to be x2, let's say, and this is going to be 2 pi minus pi on 3. And so that's going to be 6 pi on 3 minus 1 pi, so it's going to be 5 pi on 3. So these are my two base solutions. And now I need to have a look around to basically see if there's any other solutions within this domain. And remember, these are actually two infinite families. If I wanted to list all solutions, well, I could just add 2 pi and that's going to be fine. But because we're only interested in the first rotation of the circle from 0 to 2 pi, so that's from here to here, those are the only two solutions. Any others are going to be outside of that domain. Alrighty, let's repeat the same thing, but now looking at the second one. So the second one is talking about the exact value of tan x equals 1, okay? And so we can look at this one over here, and we can see no matter which one we make the opposite or the hypotenuse, you're never going to get 1. The only way we're going to get that is using the other triangle. So let's draw in the 45-degree triangle. Now in this case I'm using degrees because, as you can see in the domain, it is in degrees. And this triangle is the 1, 1, root 2 triangle. And so opposite adjacent or adjacent opposite, it doesn't matter. The reference angle we've got is x is equal to 45 degrees in some regard. Using the unit circle, we can actually work it out properly. So, all stations to central, and you can see if I draw my 45-degree angle here, why in this region? Well, because 10 needs to be positive, and in the all and in the 10 quadrants, that is where you're going to get 10 is going to be positive. So the first one's actually really easy. x1 is just 45 degrees. And then x2, a second basic solution, well, that's 180 degrees plus 45 degrees. That's 225 degrees. Okay? So those are our two basic solutions, except you'll notice that one of those solutions does not fit in the domain we've been given. Okay? So x2 is too big. But remember, x2 isn't just one number, 225. It's actually a family of numbers, because if I add 360 degrees to that, that'd also have the exact same value, because actually, well, for 10 special, 10 if you add 180 degrees, yeah, because 10's period is actually pi. So you can add or subtract 180 degrees and you'll get the same answer. And you can even see that in the picture. These two solutions are actually the same solution. The difference between these is that I've added 180 degrees. Okay? So what can I do? Well, instead of adding 180 degrees, how about I subtract 180 degrees? So let's find another solution. Well, let's try 45 degrees minus 180 degrees. Alrighty? Well, that's going to give me negative 135 degrees. Okay? And that is within this domain, so that is an actual solution. So our two solutions are x is equal to 45 degrees or x is equal to negative 135 degrees. Right? And again, there's an infinite number of solutions. It's just that these are the two that fit within this domain. See you in the next one. Goodbye.